Okay, hello everyone. I'm Chao Guy. Okay, the content of this section is not what this course is going to cover. It's just a placeholder here, something like an extension, a guide, or an assignment. In the AssetManager, we are going to add two new files here. You can see that we no longer have this text here, nor this new text. Actually, our content is all complete. Just need to package it. Before we package it, I'll add a little bit of this placeholder content for everyone. It's like leaving some room for you to advance. Right. Actually, there's still a lot of content we haven't covered, but most of the content we wanted to cover is already done. The new class we are going to create is called Gamma Data. It is also an asset. Okay, it is also an asset. After it finishes creating, let's refresh it. Okay, let's reload it. Then we come here. It's simple, so I'll just paste it directly. First, it's still like this. We need to include the input key, then include our reflection, possibly do some necessary forward declarations. Then, in this place, we take it from the subclass, something like that. Quite interesting. Put it here. Then it is an asset. Then, this asset is mainly used to mark some default gameplay effects. These effects, you might sometime need to use them. Then we will create a simple implementation of its two methods. Okay. So how is the code here done? First, we need to include our asset manager. We'll ignore this. Then here, we directly let it get into our method called getCampData, but we don't have it yet because this is an asset. Let's check where we should write the path for this asset. We go to our game asset manager here. Then, first in the position below, we put soft object pete. This is a soft reference. And with this soft reference, we need to write many methods to get this thing done. So how do we do it? We write it here. We write it at this gate. We should have a gate method. We don't have a gate method yet. Let's write the gate method. Let's write the gate method in this position. That is, we can get our singleton. Because it is a singleton, so how do we get the singleton? Let's create it. First, our engine must exist. Because this thing is obtained through the engine configuration engine, then we directly go to the engine to get our SimGene pager. You can see that this is the engine class. Here are some configurations. We just need to get this singleton. If we don't guess it, then I consider this a fatal error. Let's run through it. This is a fatal error. This is it should crash directly here. Okay, then this is our get method. So we need a getTime data. We put it in this position. Then for this getTime data, we need to forward declare it. Okay, so how do we get this data? Because it is a soft reference when you want to retrieve it. You definitely must obey a specific thing. So how do we get it? We get it through this method. We still need to continue writing this method. That is get or load typed game data. That is load the thing under the soft reference path. And its type is this, converted to this type. And we haven't written this method yet. So now let's write this method. As for this method, we write it at this position. It is a template method because it may reference other original sources. You can also write it like this. So it is a template. Therefore, we first need to give a template definition. We define this thing to be passed in. It is a template. Then we write the signature of the function. We use const for everything because this data does not allow modification at runtime. Then, how to do this? Then we first look for it at this position in one of our containers. We check in the container to see if we can find it. If we can find it, then we will throw this thing out. So what is this thing? We haven't written it yet, right? So let's write this thing first. This thing is a container. It specifically points to the actual instance object based on the U class type. It's a bit like the concept of CDO. You just need to pass a U plus type here. Then you can find this thing. If you can find it, it means we have already loaded it. If you didn't find it, it means it hasn't been loaded yet. So if it's not found, we must load it. Then we use the landGame data of class method to load it. This is also a template method. Then we need to pass these things. Just pass this path. Then in its reflection class, its name, and then load it here. Now let's write this. landCam game of data method. As for this method, we'll just write it below here. Okay, just this method. This is a cast conversion in front. There shouldn't be much to say. This method, how do we implement it? Because what you currently have is actually just a path. Actually, your approach is essentially to load object. And then here, we first set this asset as a null pointer. And then here, it might need to do some. What we call can is to do some ret calculations for performance. So how long will it take to load this thing? Then this thing, first, this cast. This thing cannot be empty. If it's empty, you won't know what it is. So if we are under the editor, we can do some things like performance checks. Then you just paste this thing and leave it. And you're done. As for what it specifically is, you can check it later. Okay, so here we print a log. The counterpart of this log should also be included. Okay, then we also need to make another judgment. That is to say, under this editor, we might still need to do some other work. We can just do it here. Okay, then if it's not under the editor, actually we can just load it directly here. Here it is, a load singles. Here, just take this soft reference and load it out. This part should be, let me check. It's a map folder attached to it. Yes, it loads the type of tissue paper, and it's this kind of method. Okay, then if we go down below, then we, at this point, directly here, we just need this, get this handle. Then we wait here for it to complete. That's the way to handle it. Okay, this is a dedicated one-step asset loading, and this handle is often used. After the processing here is done, actually, through this series of things, we should have finished loading our asset. It should no longer be empty. We will put it below. So if it is not empty, then we will put it into our container. After putting it into the container, we will give it here. If it is still empty, it proves there is a problem here. It should be a fatal error. Normally, it should be able to load it in. We will return this asset. So actually with this method, we have cleaned it up. We can compile it. Let's check if there is anything missing. Then we will continue writing some other methods. Then, let me take a look. This place for slow get load. Then, we can actually, based on the original reference, directly load this object out. We can load it using the new asset method. Then, we wrote a method here. It takes an original reference as input. Then, I'll just paste this method in directly here. Okay, this should look like a synchronous loading method. Then, here there is something called shouldLog as. What does this thing do? We'll write this method in. As for this method, it actually determines whether this exists in your command line. Whether you need to print this. If you can parse this out in your command line, then this place will be true. And then here, it may need to do some date and time, some judgment on loading time, some processing. Okay. Then next here there will be a thread-safe method for processing the related assets. Such a method. Then we can see here a UObject is passed in. Then after passing in the UObject, he confirms this place. It will definitely ensure that this asset exists. Then similarly add a number. Then add it to this loaded asset. And this loadies, we write it below, just upward. This is a T set. That is, you might want it to hold some loads. Or have it hold to this position. So there's a lock here. After writing it like this part is done. Okay. Then let's compile it. There should be no problem. Okay, then there is actually a template method here. That is to say, this is also a template method. Template method. So here you can load assets of this type. We can compile it. Okay, so the compilation didn't pass, right? Then it should be here. Let's find it. Usually it's missing a header file. Let's write the header here. Writing it under this get should be fine. Okay, compilation succeeded. Next, we can take a quick look how it is used. It's just the related code. We are just giving a demonstration. We go into our hairs cumber. Actually, we left an empty spot for you back then. Left an empty spot right here. There is a function called let's find it. Damage save all. This function. As for this function, it is usually used for letting us self-destruct. Maybe you want to implement a self-destruction of this gameplay. Such a feature. Let it go through this destruction process. When you are testing or when triggering other effects, it is quite useful. You might need to use this damage safe, destruct. Then everyone might determine if it is out of bounds, falling out of the world. This out of bounds is not a numerical overflow. It means exceeding the game boundary. Here the absorption becomes quite troublesome. It is a bit too much. Then we will paste it and let everyone take a look one by one. We won't test this code either. Test it. Actually, it's humidity. We help him get the same key. Okay, all of this specific stuff in here is Lyra's code. If you're interested, you can dive deeper into learning Lyra. This is considered an advanced project. Okay, now let's go back to our self-destruct here. So here we definitely need to check whether it is currently not dead. You must not be dead to die. So how do we die here? First, we find a memory. This memory is obtained through our AssetManager to find the gamma data thing. After finding this memory, let's assign some tags to it. That is, these tags are because we drowned or suffocated or fell to death. Then just apply this gamma effect to it and that's it. Okay, so this is a simple application idea. Because it may have some gamma effects, it has a parent-child relationship. After this is done, we go to our project. Let's configure this asset. Okay, we have now opened the project. Then we come to our place here. For things like this, we usually like to put them in this position. We create a new asset here. As for this asset, we put it here. We call it game data, right? Game data should be this. We name it default. Game data. So this game data, it actually needs to specify 3 game effects. As for these game effects, we put them here. We create a new one. We won't use this thing. Not using it. Gameplay effects. Then we just need to create a few new game effects here. Game effect. Then we just create 3 of them. This deep parent-child relationship of ours, we'll just ignore it. We'll give it this. Just give it any name. Okay, the reason for doing this is mainly for convenience here. That is if it wants to attach some tags at its parent level. For example, attach some tags here. For example, tags like effect as well, and then like this. Because it may have some are all damage from death. Some may be full damage. Some are other types of damage. In this place, you can give a basic type. For example, here, we can give it a, maybe need to add a new tag. We hit game, play, effects, then click damage type, then click this basic. Let's put it here. That's roughly the idea. It means it can do many parent-child level restrictions. Okay, let's specify it here. We can just pick one randomly here. We can just pick this set by cleaner randomly. Then for this damage attack, we'll also create a new one. We'll paste it here, then we'll name it memory damage attack. Okay, then here, we need to modify the input. Okay, this is actually a configuration, but after you write it like this, it doesn't actually take effect. If you want it to take effect, you need to do it in this. Find our asset manager in the project settings. There should be a place where we can configure it. Let's find this location. Then you'll find that you just can't find it here no matter what. This is quite frustrating, but there's nothing we can do about it because this is a hard-coded thing. Actually, how do you change this thing? If you want to find it, you have to configure it in this place. Let's go to our default Dutch cap.ia. Actually, it needs to be written like this. You can see in Lyra, it is written like this. You'll search for it in AllStrike. You will find it is in default Kindini. There will be a configuration like this here. So for our part here, we need to write it like this. That should be enough. Then here we change the name. XGRPG. And the path here should be game. Here, see XGRPG. And here it is, XGRPG. MixGRPG. And here it should be the module name XGRPG. It should be like this. In that case, this way, he can take responsibility for this thing. Specifically, we can set a page and check, see if he can read this character. Let's take a look. Let's set a breakpoint right here. Then you'll see that when we break at this position, it actually reads this ascent path. Right, that's roughly it. Now we just need to start it. So regarding this part, the configuration here is actually a bit troublesome because Nira is often configured this way, and many of its configurations are scattered. Okay, so this project of ours should be about done by now. Okay, let me show you. In the next lesson, we'll package it for you. And this section is quite difficult. You need to go online and study it in depth. You need to study it deeply. We're just leaving a placeholder here. Okay, you might find this part unsatisfactory. I also think it's not very satisfactory. Because it might. The anchor point of this UI might have an issue. Because I directly pasted the UI over, it might not have had the anchor point set. This anchor should be anchored to the left. Let's take a look now. Otherwise, it's sometimes convenient to see on small screens. Okay, it looks a bit better now. Let's click it. You can see the attack power here. Right? Let's take a potion. Right, let's swap and swap here. But swapping here won't work. Putting it back here is still okay. Okay, alright. That's all for our overall content. Thank you very much. In the next lesson, we will start packaging for you.